What I stumbled on today, kind of like a revelation, was how to use two things that we've used in the past. And the two things would be, first of all, this thing of periodic table, mole ratio, and AVO in connection with this stuff up here, which is showing how we have to move to go from grams to particle, or from any part of this to any other part of this. And we've used this a lot, so this is nothing new. But using it the way I'm doing is going to be a new way to look at it and a way to help. And the best way to do this is to show you an example. So here we go. If you get this as an example, you'll notice that H2SO4, also known as sulfuric acid, is the same particle in both the given and the find. Because I know that, I'm going to cross out moles, or at least one of the moles, because I know I don't need it. Okay? I only need one of those moles. So, now, let's see where we're actually at. We're going to draw an arrow to where we are right now. Where should I put that arrow, class? Where are we at the given? The second moles, aren't we? Okay. So we're starting right here. And because we're starting there and we are going here, I don't need to look at the rest of that, do I? Now I have just described my entire problem. Look, that much. Nice, huh? Isn't that great? Now we can see graphically, and your mind thinks best in graphics, where we're going and where we're coming from. So we're coming from moles and we're going to particles. Does that make sense? Okay. Now, are we going to need PT for this? No, there's no grams anywhere, so why use a PT? So I'm going to cross that out. Cross that off the list. And we're starting, am I going to need a mole ratio? No. Oh boy, this really gets easy, doesn't it? The only thing I need is AVO. Our good friend AVO. You love his sandwiches. Anyway, moving on. I don't think anybody's going to have a problem with this. 0.0425 moles H2SO4. All right, over 1. All right, what's next? What do we have to have on the bottom of this second fraction? 1 mole. Right, mole has to be on the bottom. 1 mole of H2SO4 and 6.02 times 10 to the 23rd H2SO4s. That's our particle. No change in particles, no need for mole ratio. So, we're actually using this guy, aren't we? That's the only thing we're using. This should help you settle in your mind some things that, when do I need 3 fractions? When do I need 4 fractions? When do I need just 2? Like in this problem, yeah? So now we do the numbers. Let's get out the calculators. And what's the first number I put in my calculator to make this calculation? Come on, what is it? 0.0425, right on. And now the 6.02, is that going to be a multiply or a divide? Multiply. So I've hit the times key. 6.02, and I get a number. Looks like this. 0.04, whoops. Reading the wrong place in my calculator. 25, and I'm going to round to 3/6. Okay, I actually get 0.2558, and so I'm going to make that 0.256, and that's just a rounding. And then I can't throw away my power of 10, so I put that up there as 23, 10 to the 23rd, and I have just done a conversion, and I now have particles of H2SO4. And now what I want to do is go down a little bit and do this. I'm going to extend my page. Where do I have to move my decimal? To the right, correct? Okay, when we move to the right, what happens to the power of 10? It goes down. So I'm going to subtract 1 from the 23, and that becomes 22. And then here, we're moving the decimal to 2.56, and this is H2SO4. And we are there. That is our answer. Okay. How are we doing? Wasn't that nice? This is a great little method. Let's go on to another problem. Okay, I'm going to get rid of all this stuff, I hope. Yeah, is that available to me? Okay, I'm going to stop the recording just a minute. Okay, here's a second problem that's going to use everything. So let's see how that's going to work. First of all, where am I starting out in this problem? At grams or particles? Grams, right. Okay, so my arrow is right here. Where am I going? I'm going to particles. Whoa, right over here. I got to use them all. Now the only question is, do I need to use a mole ratio? And I'll show you how to make that decision. Are you ready for this? Oh, this is so wonderful. I look right here. Is that the same as that? How many chloride ions? Are these the same particle? Oh. This is calcium chloride, this is chloride ions. The particle is changing, isn't it? Okay. So, that means I'm going to have to use a mole ratio. To get from grams to moles, what do I need? What do I need? Grams to moles. PT. See, I'm taking out all of my possibilities. And will AVO be needed along the way? To get to particles, will we need AVO? Oh, definitely. Okay, let's see how it all goes down. We'll start out with the given over 1. 2.50 grams of calcium chloride over 1. Okay, now I've got to do a molar mass, huh? Okay, I'm going to stop the recording to shorten the video, and we're going to do the molar mass. Okay, so what we realized is that our first step is going to have to be a periodic table job. So I started the molar mass thing down here. And so I said, we got 1 calcium in this molecule, and that's multiplied by 40 because that's the molar mass of calcium on the periodic table. I took away all the decimals because I want to keep this simple, so we can concentrate on what is actually happening in this whole thing. So I had 2 chlorines at 35.4, so I just rounded that to 35, and now we're going to get some numbers and get a total. So here we have 40, here we have 70, we add those together and we got 110. So this is my periodic table step. What has to go on the bottom? Grams or moles? Grams. Okay, so this is the grams down here that equals 1 mole of calcium chloride, Cl2. Okay, so this is 110 grams, CaC CaCl2 is equal to 1 mole CaCl2. Whoops, we're not going to do an equal, we're going to do more times. Now, where am I after I get this part up? I am sitting right on the verge of the mole ratio. Okay, I'm going to need the mole ratio. I check that off over here at my list on the left. So what is the mole ratio we need? I'm going to get rid of this molar mass so I have room here. Because now we need to concentrate on the mole ratio. And with the mole ratio, I'm going to use a different color because we're changing to a different substance now. So what's the ratio in the molecule calcium chloride of calcium to chlorine? What is it? 1 to 2. One of these has 2 of these. Yeah? So, which one has to be on the bottom? Calcium chloride or chlorine? You're going to have to, here, just a second. Let's do the cancellation for the first part that I did. Okay, we canceled grams and calcium chloride, and we still have calcium chloride when we have moles. But now we want to use the mole ratio to get into chloride. So, how many calcium chlorides do I have in that ratio? 1. Okay, so 1 mole calcium chloride is equal to 2 moles of chloride ions. Yes? Because in the molecule, right here, one molecule has how many calciums? How many chlorines? Yeah. That's why this has to be 2. Okay? Because the number of atoms in the molecule becomes a mole ratio. Okay, that was a good clarifying question. Thank you for asking. Okay, now we're going to continue in our new substance. But first of all, we want to cancel our moles and our calcium chlorides. Okay, where am I now? Where do I move my green arrow to? Another mole, yeah. Okay, and just for fun, let's label what this mole is. It's calcium chloride moles, and this is chloride ion moles. That's where we make the change to the new substance. Okay? And now, our last fraction is going to be what? Avogadro. Whee! Yeah. So, what's the number on the bottom? You want to put particles on the bottom? You can't cancel moles, which you have right here. Can't cancel that with particles, can you? So what has to be on the bottom? Mole. Of what? Yeah, 1 mole. Of what? Chloride ion. Yeah, chloride ion. 1 minus. And what has to be on the top? 6.02. Yep. Times 10 to the 23rd calcium, or chloride, ions. Okay? And now it's just a matter of doing the numbers. We got to cancel. So we're going to cancel this mole of chloride ions with this mole of chloride ions. And now, up here, we have no unit of measure, so it's just the chloride particles. That's how we know it's particles. Okay? So, get out your calculators. Let's run it. Are you ready? Here we go. What's the first number we put in? 2.50. We don't need to put in the 0. Calculator doesn't know the difference. Especially when it's a decimal like this. So, after the 2.50, are we going to multiply or divide the 110 down here? That is divide. So we put divide on our calculator. And we put in the 6.02. Where's this going to go? multiply or divide? This is multiply. So we put in the times, and we put in our 2. And now what about this guy? Multiply or divide? Multiply again. So times 6.02, and that's going to be our answer, except for the power of 10. So I'm going to hit the equal sign. What do you all get? 0.274. Did everybody else get that? Okay, 0.274. So over here in our answer we have 0.274. Yes. I'm just using 3 6 right now. This guy does not limit our accuracy.
Yeah, but the first and second
The
numbers?
first number? No. No. This has 3 sig figs.
What about 110?
This has 3 sig figs also, because it should have a decimal. Okay, should have a decimal. Because I rounded, and that became a significant number. But that was a good clarifying question. I appreciate it. But these guys over here, this 2 and this 1, those will never limit your accuracy because they're definitions. It's defining a ratio of chlorines to calcium chloride, and that's infinitely accurate. So never lose accuracy with a definition. And then down here at the 6.02, well, we're in good place here. So let's continue on and finish this off. What do we put after that? Yeah, we got to have the 10 to the power of 23. And now what we need is to get ourselves in scientific notation. I'm going to move this up so everyone in the class can see. And where am I going to move my decimal to? Right over there, right? When I move to the right, what happens to the power of 10? It's going to go down, isn't it? Yeah. We go down when we move the decimal to the right. We go up when we move it to the left. So this becomes 10 to the 22. And then our number is 2.74. And this is chloride ions. And we are done. With this little method, you can use my stuff across the top and my stuff across the left side, or up and down on the left, to figure out, first of all, where you are. And by the way, we ended up here, didn't we? Isn't that where we ended? Yeah? Okay, so we are where we wanted to be. We have gone through grams of calcium chloride to moles of calcium chloride with this guy, and we did moles to moles with this guy, and we did moles to particles with this guy. And I hope you find this helpful. This is a great little way to think of the progression in any calculation. We can also go the other way, by the way. There's no reason why you can't go backwards. It will just mean that the fractions will be upside down when you use them. If I started with particles, I could demonstrate here real quickly that these particles that I just got in my answer will come right back to the same number of grams. Okay? Enjoy. I hope this helped a lot.